In this video, we're going to look at the distributive property in algebra. So we're going to look at a problem that's very similar to the last problem we looked at. However, we're going to insert an algebraic component. So let's read through the problem and then we'll see how that works out. Elsa is making a rectangular flower bed that is 10 feet long. She hasn't decided how wide to make the flower bed yet, so she is labeling it as x feet wide. So x is going to represent the unknown width of the flower bed. She is going to plant morning glories and tulips. She wants more morning glories than tulips and decides to divide the garden as shown below. So notice this is just like the last garden. The length is going to be 10 feet. The tulips are going to have a length of 3 feet and the morning glories 7 feet. But now the width is x feet. It's unknown. Okay, but we can still find these areas, so that's what we're going to do. So the first problem says, determine the total area of the garden by multiplying its length times its width times its total length. Okay, so its width is x feet, and we want to multiply by 10 feet. Okay, and now remember in the last problem, this x was 4, we had a specific value. Okay, here we don't, but we can still multiply x times 10. It is 10x. Remember, we write the number in front of the variable in general, and we put them next to each other to imply multiplication, and the units are feet squared. Now let's look at the next one. Determine the total number of square feet that will be planted with tulips. So here's the tulips. We have this dimension is 3 feet. Notice this side is the same as this side, so we can also say this is x feet. Okay, so the area of tulips will be 3 feet times x feet. Notice I changed the direction there. So 3 times x is 3x, and the units are square feet. Now we will determine the number of square feet that will be planted with morning glories. So here's the morning glories. Notice this is 7 feet by x feet. So 7 feet times x feet. And that's 7 times x is 7x, and the units are feet squared. Okay. Now we're asked to determine the total area of the garden by adding the area planted with tulips and the area planted with morning glories. So just like we did last time, but now we don't have numbers, we have these algebraic expressions. We want to add 3x plus 7x. Okay. Now this is 3 copies of x plus 7 copies of x. Okay. And basically, this result is what we're about to show, but if we have 3 of something plus 7 of something, our result is going to be 10 of that something. Okay. And we're going to justify that a little bit better in a second, but notice this corresponds to our first answer when we found the total area. Okay. Now it says, using the equation below, describe in words how it represents the 2 ways we found the total area of the garden. Well, the x times 3, remember that was the tulips. The x times 7 was the morning glories. And if we add those quantities together, we get the total garden, which I'll call G. Okay, so notice this is x times the sum of 3 plus 7. So when I added 3x plus 7x, okay, notice that's equivalent to adding the 3 plus 7 to get 10 and multiplying it by the result x. Okay. So then it says, use this information from part E to explain why 3x plus 7x equals 10x. Well, that's kind of what I just did, but we'll just say part A, the total garden equals 10x, and that equals from part D, put part D above, 3x plus 7x. Okay, and all we need to do to get from here to here is juxtaposition, move the 3 and the x by the commutative property, and then remove the multiplication sign. So x times 3 is 3x, x times 7 is 7x, and now we know that the result is 10x. So here's why this is going to be very important in algebra. There's 2 ways we're going to need this. Okay? So here we have multiplication over addition. If we want to multiply x times 1 plus 2, we could think of this as x times 1 plus x times 2, which equals x plus 2x. So notice we're going to mainly use this in the other direction. So x is the same as 1x. We don't write the coefficient of 1, but remember it's implied. If we want to add 1x plus 2x together, we now know that this is the same as x times 3, or 3x. So basically, to add what we're going to call like terms in just a minute, okay, you add the coefficients. And here's another example. If we had 2 times x plus 3 in parentheses, right now we can't compute the multiplication because we need to do the addition first. But we can't do the addition first because we don't know what x is. But we just learned from the distributive property that I can multiply the 2 by each of these terms and add the results. So this is 2 times x plus 2 times 3. And then simplifying gives us 2x plus 6. Okay? And the same results hold over subtraction. Okay, so in the next video, we're going to do quite a few examples looking at these 2 key ideas using the distributive property.